Hello everyone, this is Zahid Bashir. I am a faculty member at Department of Commerce, University of Gujarat, and a PhD scholar at Delhi College of Commerce, University of Punjab, Lahore. Today is the 27th training day on SPSS, and I am considering to discuss the different cases of regression. And previously, I have discussed the case number 6, where the independent variable was categorical, means binary, and your dependent variable is also binary. Today, I am going to discuss the case number 7, where your independent variables contains more than two categories. It means it may have some categorical dimensions with more than two categories, and dependent variable is binary. So let's go straight to the case number 7. As I have already mentioned that I have shared the relevant data set with both of my participants. So this is the specific detail of case number 7, where your independent variable contains more than two categories, and your dependent variable is basically binary, which means that it will be coded by 0 and 1. So our major concern is there any effect of age groups, different number of age groups, maybe more than two age groups, on the chronic heart disease status? So our null hypothesis is there is no effect of age groups on chronic heart disease status. And our alternative hypothesis is there is an effect of age groups on the chronic heart disease status. So when the categories of our independent variable are more than two, then first we need to create a dummy variable, same as we did in case number 4. Since the total age groups are 8, first we will need to create 7 dummy variable. Then we need to run the binary logistic regression, and then we need to follow the same steps that we have previously followed. So as a first step, we need to create the dummy variable. So what is the criteria for creating a dummy variable? Let me open a data set. Uh, as we are discussing the case number 7, so we are going to consider the case number 7 data set. So let me open this data set. So as it is opened, you can see there are a lot of variables here. Uh, you can see already I have created some variable here relevant to age. So for your consideration, I have basically deleted. So I need to consider the chronic heart disease and age groups here. These are two variables that you need to consider. This is the independent variable. If you see here, there are 8 categories of age. The first category of age represent below 30 years. The second, 31 to 34. The third, 35 to 39, and so on. So there are 8 categories of age. Always remember that when you need to create some dummy variable based on some categories, always consider one category as a reference category. So we can consider uh, the first category as a reference category, and we need to create the other as a dummy variable. So we need to create the dummy variable here. While our dependent variable is chronic heart disease, which is represented by CHD, you can see here it is coded with 0 and 1. So 0 represent there is no chronic heart disease, while 1 represent there is chronic heart disease. So our major focus is on age group and chronic heart disease. So as a first step, we need to create the dummy variable. As we have 8 age groups, so by considering the first age group as a reference category, we can create 7 dummy variables. So we go to transform, we go to recode into different variables here. We need to consider the age groups here from, and we need to write here dummy age 1. So we can write here the age 1. Change old and new values. If you see here, I need to show you something. Uh, because we are starting with second category, because first category is the reference category. So the second category, old value of the second category would be 2. So for measuring its impact, we need to consider 2 into 1 and consider all other values as a 0. So this is the procedure that we have followed in our case number 4 for creating the dummy variable. So if you see here, it is created, click on OK. You can verify here the first dummy variable has been created. You can see here the first category is the reference category, while from the second category, it is 31 to 34 year. So its old value is 2. So third category, old value is 3. Fourth category, old value is 4. So we need to consider that we need to consider their old value as their reference, as their category code number, and we need to convert it into 1 for measuring their impact. So we need to create the second dummy variable in the same way. So recode into different, reset. Again, consider the age category here. Dummy age 2. So the age 2 change old and new values. Old value is 3 and new value will become 1 because we are measuring the impact. So all other values become 0 like this. So click on continue, click on OK. So second dummy variable has been created. You can see here. This is the second dummy variable. So after it, you can go to transform, recode into different variable, reset. You need to put age into it, dummy age 3. So the age 3 change old and new values. Old value would be 4 and new value would be 1. Add. So all other values become zeros. Continue. Okay. So the next dummy variable has been created with the name age 3. Then we can create another dummy variable, reset, put it again, and dummy variable age 5. Because age 4 has been, age 3 has been created, so it will become age 4, sorry. So the age 4 change old and new values. So old values was 4, new value 1, add, all other values becomes 0, like this, and continue. Click on OK. So dummy 4 has been created in the same way. We go to here and we need to reset it again, and we need to consider dummy 5, dummy age 5. Mm, dummy age 5. Let me confirm one thing. Maybe I have considered something wrong here. Yes, the age 4 is not clear here. Basically, we need to see here one thing. in the variable view. If we go to here, old number is 2, old number is 3, old number is 4, old number is 5. So with age 4 as a dummy variable, we need to consider 5 as a whole number. So transform, recode, dummy age 4, the age 4. So with age 4 means that whole number was 5. So we go here, we put 5 here, consider it as a 1 and all other values as a 0, like this. Now it is corrected. So go to transform, go to recode, reset it again, and put the next dummy variable. So dummy age 5. So D age 5 here, change. Old value would be 6. New value would be 1. All other values becomes 0 and continue. Click OK. Fifth variable is created. 2 more to go. We need 2 more dummy variables here. So again, put age here, dummy age 6, B age 6, change here, old and new values. Old value would be 7, new value would be 1. All other values becomes 0. Continue. Okay. So go to transform. One last dummy variable we need to create here. Reset. Put it here the age. Dummy age 7. D age 7. Change. Old and new value. Old value would be 8. New value would be 1. All other values 0. So here it comes. We have created 7 dummy variables here. So you can verify here 1, 2, 3, 4, 5, 6, and 7. As I have mentioned that I will consider the first as a reference category. So we have created 7 dummy variables from 2 to 8 by excluding the first one. So we have completed the first step, create the 7 dummy variable of age groups. Now the second step is to run the binary logistic regression DV, status of heart disease and IV, different age groups, in order to create a predictive model. So we go to here, go to analyze, go to regression, go to binary logistic regression. So we can consider here the dependent variable chronic heart disease and independent variables are different age groups here like this. And we can click on OK and it will gives us the results. So we need to ignore the block 0. We need to consider the block 1 result. You can see here the model is statistically fit because this value is less than 5%. And you can see the Cox and Snail R square, it is 24.9%. It means all of the age categories are basically explaining the chronic heart disease approximately 25%. Then you can see the accuracy of your predictive model. It is 74%. So it is Good prediction here. Now you can see the impact of your different variables here. You can see that some of your variables are showing the significant impact and some of your variables are not showing the significant impact. For example, the first dummy variable, which is representing the age category from 31 to 34 years, is not significant here. In the same way, age 2 is not significant here, age 3 is not significant, while age 4 is weakly significant. Age 5 is also significant, age 6 is significant, age 7 is also significant. So always remember, whenever you need to create a predictive model, you need to consider only those variables which are significant here. So in order to correctly identify your model. So we can rerun the model based on age 4, age 5, age 6, and age 7. So go to Analyze, go to Regression, Binary Logistic, and we can remove the first three dummy variables here because they are not significant. We cannot accurately predict on the basis of the excluded variables. Now you can see here again the block 1 results. Model is statistically fit. Cox and R square 22.8%. Accuracy is still 74%, and you can see here uh, the age 4, age 5, age 6, and age 7 all are significant here. So we can create a predictive model on the basis of these variables. So in order to create a predictive model, if you remember, uh, first of all, we need to create a predictive model on the basis of Z distribution. So for creating it, we need to have a constant value, which is negative here, and all remaining are basically the positive values. So go to transform, go to compute variable here. We need to consider here the Z distribution. So go to numeric expression. First of all, we need to consider the constant value here, which is negative. So put here negative sign, 1.316, which is basically the value of constant. Then you can put one by one the coefficients. So we can put here the positive sign. The first coefficient with dummy variable age 4 is 1.162, and it is positive value. And you can multiply this value with your age 4 dummy. So age 4 dummy is here. You need to double click it. Then you can again put a positive sign, and you need to put the coefficient value of age 5 dummy. Age 5 dummy, that is 1.827, 1.827, and then multiplication. I need to put here the value 1.827, 1.827, then multiplication, dummy variable 5, then plus sign, and then age 6, 2.494, 2.494, then steric with dummy variable age 6, then plus sign, 2.702, 2.702, then static, and then dummy variable 7. So this is how you can create your predictive model. So click on OK, and your predictive model is created. It means your Z distribution has been created. You can see here. You can also verify the values of your Z score. here. So this is your z-score. This is the first step in our process has been calculated. The next step is negative z. That is the same step that we usually follow. So compute variable, reset, and we will write here negative z distribution. So you just need to place here minus, and then you need to double click on z distribution, which was calculated previously, and click on OK. You just press minus sign and then double click z distribution and then click on OK. So it will automatically calculate the negative z distribution. And the next step is exponent of z distribution. So what we need to do, we go to transform, compute variable, reset, and then exponent of negative z. So what we need to write here, exp bracket, double click negative z, bracket close, click on OK, and you need to verify here exponent of negative z has been created. Then the next step is 1 plus exponent of negative z. So you can calculate it, compute variable, reset 1 exponent z, exponent negative z. So what you need to write here, you just need to write here 1 plus and double click on exponent negative z variable, which you have created in previous step. Click on OK, and it will show you the results. You can verify from here. 1 plus exponent z has been created. After it, you need to calculate probability of having chronic heart disease. So 1 divided by exponent of negative z. So go to transform, compute variable, reset, probability of having chronic heart disease. So like it in a short form, probability of having chronic heart disease. So we can write here 1 divided by 1 exponent negative z. Just double click on it and click on OK. So it will show you the probability of having a heart disease. So this is the probability of having heart disease at different levels. You can see here. So what we need to do next? We need to create cluster bar chart, take age group variable on axis, and define cluster by probability of having heart disease. So this time you don't need to take the dummy variables here. You just need to take the age groups variable. That was the first variable before creating the dummy. And you need to define the cluster by probability of having chronic heart disease. So we go to the graph, then legacy dialog box, then bar, cluster bar charts. We need to put here category X as a age group here. And we need to define cluster by the probability of having heart disease like this, and click on OK. So it will show us the results like this. So this is the probability of having chronic heart disease. And you can see here, those having the age of 55 to 59 years have highest probability, more than 15% probability. There are more than 15 people who may have the 76% probability of having heart disease. There are approximately 10 people who are having greater than 16 years of age. They have the 80% probability of having heart disease. So these are the different scenarios you can see here. Those having the age below 30 years having, they are 10 in numbers from the sample. and they have only 21% chance of having a heart disease. So highest chances of having a heart disease is with those people who have age greater than 60. So this is how you can create the probability of having the heart disease. So this was the basically the case number 7. And next we will consider the case number 8. The case number 8 is relevant with multinomial logistic regression. So in this case, we need to see when your dependent variable having more than 2 categories. But as the procedure will change, so I will let you know the procedure of multinomial logistic tomorrow. So today, do some practice on case number 7 because it was a detailed case. We are having three more cases that we will cover tomorrow. Case number 8, case number 9, and case number 10. So they are basically related with multinomial logistic regression. So we will consider it tomorrow. So do you have any question for today's discussion, Rabia? Please let me know.
No, sir.
All right, so let's practice today's case in detail. Do practice more and more until you have a solid grip on this case, and we will consider the multinomial logistic tomorrow. So thank you very much for joining and stay tuned.